Hello everyone, welcome to Veracious Academy. My name is Anil Kumar. I am an alumni of IIT Bombay. I have done my BTech from Mechanical Engineering. I have been teaching physics for the past decade for JEE Mains, JEE Advanced, NEET UG and other competitive exams. If you are interested to attend my sessions, please find the contact details in the description below. Let's get started with this lecture. Enjoy the video. Now let us go into we also in linear charge distribution, we also did the arc thing, right?
Yes, sir.
So if we have an arc, subtending an angle 2 alpha at the center, we did all this integration part. Just tell me what is the electric field over there at the center, and let this be lambda, positive charge.
Sir, K lambda by A of
A lambda by A of
that is 2 lambda kilometers.
radius. Let's take the radius as r. So we have solved it in
Sir, you want the general case or
we did the derivation for this.
Yes, sir.
We took
K
it.
lambda root to K lambda by A.
I
Okay,
can.
sir, this is J cap, sir.
Yeah, but we don't have to specify any I cap, J cap. So let the electric field be E, not the vector form. So just tell me what the magnitude did we get? K lambda E is equal to K lambda by
2K lambda sine alpha by R, sir.
2K lambda sine alpha by R.
Yes, sir.
Right?
Yes, sir.
See, you need to remember this also. After this, we did some special cases for quarter of a circle, for semicircle.
Yes, sir.
Right? So for quarter of a circle, I'll substitute alpha as
5 by 4. No, 5. Yeah.
correct. Alpha is pi by 4. For quarter of a circle, I will have alpha as pi by 4. And if you remember, we solved it in terms of Q, total charge Q.
Yes, sir.
Right? So, and also we solved it in terms of lambda, and that is where I told you that solving it in terms of lambda makes life easier.
Yeah, sir.
Okay, so if suppose this itself is, if the total charge is Q, and so if you remember, what is lambda for us over here? If the total charge is Q, we have total charge divided by the total length.
No.
2 alpha R. You remember this? If the total charge is Q, lambda is total charge Q divided by the length of this. What is length of this? R times the angle subtending
Yes, sir.
R times the angle subtending at the center. Right?
Yes, sir.
Is this clear?
Yes, sir.
We substituted this fellow over here.
Yes,
and
sir.
if you remember, we got that KQ by R square into sine alpha by alpha.
Yes, sir.
I told you to remember this fellow also. Right?
Yes, sir. I didn't write that.
Okay. Write that down. We solved quarter of a circle, we solved semicircle,
Yes,
taking this as the formula. But lambda makes a lot of questions easier, because
Yes,
questions
sir.
also come on the basis of lambda.
I wrote it.
Done?
Yes, sir.
So mostly today I will not use that total charge story. I will only use the lambda one. Okay.
Yes, sir.
I'll remove this off, and I'll also remove the capital Q, and I'll also remove this one. Today we will use only this much information. Is this clear?
Yes, sir.
Now let us go to the question number 9.
8. 9, sir.
9, right? Okay, so let us say I have a quarter of a circle and a semi-infinite wire. So this is a quarter of a circle and this is a semi-infinite wire. Both have the charge per unit length as lambda.
Yes, sir.
Okay. What is the radius of this quarter of a circle? The radius of the quarter of this circle is basically, take it as A.
Yes, sir.
Okay, and this is the center of the circle.
The electric field at that.
Electric field at the center. We need to find the electric field at the center. So let us say this is my quarter of a circle. The radius is A. Okay. Let's say this point is P. So find the electric field at point P in terms of I cap and J cap. Okay, due to both quarter of a circle and also the semi-infinite wire. Okay.
Yes, sir.
First, let me solve it. Next one, you solve it. Okay.
Okay.
There is a possibility that you might go wrong. So first, easy fellow is this semi-infinite wire. The semi-infinite wire is going to have k lambda by a in this direction and k lambda by a in this direction. There is no problem.
Yes, sir.
Right? Now, what is the electric field due to quarter of a circle? Quarter of a circle means alpha is pi by 4. Right?
Yes, sir.
So sine 45 1 by root 2.
Yes, sir.
So I will have electric field as k lambda root 2 divided by a.
Yes, sir.
Okay, so let me write it over here. The electric field due to the quarter of the circle. So my alpha over here automatically becomes 45 degree, right?
Yes, sir.
I'll substitute this fellow. So 2k lambda upon radius is a into sine 45 degree, and sine 45 is 1 by root 2. So 2 by root 2 will become root 2.
Yes, sir.
Therefore, I can write this as k lambda root 2 upon a. Fine.
Yes, sir.
So this is just due to the quarter of a circle. That's it. Fine.
Yes, sir.
Why? What problem I said that there might be, a chance that you make a mistake is I have to write it in terms of I cap and J cap. First, I have to identify that this angle is 45 degree because the electric field will be along the angular bisector.
Yes, sir.
Because this is quarter of a circle, this entire angle will be 90 degree. Therefore, this angle will be 45 degree.
Yes, sir.
That means to write it in terms of I cap and J cap, I have to take the components of this vector.
Yes, sir.
Correct? So components of that vector, I will just draw it over here. So if I have k lambda root 2 upon a in that direction, so the component of this
both the components will be k lambda by a.
Good. K lambda by a and k lambda by a. Because if I have two vectors, yes, if I have two vectors of magnitude anything L, right angles to each other, the resultant will be L root 2. Correct?
Yes, sir.
So automatically I can say that this component will be k lambda by a and this also will be k lambda by a. So from here I can say the electric field at point P in terms of I cap and J cap, I cap will cancel each other.
Yes, sir.
Everything will be along j cap, and it is 2k lambda by a j cap. Is this
J.
clear?
Yes, sir.
Hi guys, I hope you enjoyed this session. If you think this video was useful, don't forget to like, share and subscribe to my channel. Also, I'll be waiting for your comments in the comment section. See you in the next video.